Lesson 7-2, Adding and Subtracting Polynomials. In the last lesson we talked about what it was to be a polynomial. Now we're going to talk about adding and subtracting polynomials. When adding polynomials, we ignore the parentheses, identify our like terms, and collect like terms by adding the coefficients together. For example, a couple of examples. Here I'm adding two trinomials. I ignore the parentheses. I identify like terms, 5x squared and 2x squared, 3x and negative 7x, negative 6 and negative 11. These are my like terms. So I collect like terms by adding the coefficients together. I'm going to go ahead and rewrite them next to each other. You don't have to do this step, but if it helps you, you can do this step. Just be sure to keep all of the signs the same as you go through. 5x squared and 2x squared is 7x squared. 3x and negative 7x, I have 3 plus negative 7, so that's negative 4x. And then negative 6 and negative 11 is negative 17. Now I can't combine an x squared and a negative 4x because the exponent portions don't match and they have to match exactly. Here I'm adding a trinomial and a binomial. I have 7x squared. I don't have any other x squared, so I'll just write that one down by itself. I have 2x and 6x. And then I have 12 and negative 5. Since 7x squared had nothing like it, again, I just write it down. 2 plus 6 is 8, so that's 8x. 12 minus 5 is 7. Here I've got a binomial plus a trinomial. 13x and negative 5x are alike. And then I have a negative 5 and a positive 1. And then I have a 10xy. But that doesn't have anything like it. Let's try that again. My pen is acting up. Okay, so 13 minus 5 is 8x. Negative 5 plus 1 is negative 4. And then again, I have that 10xy. Here I have two trinomials, 3x squared y. I don't have any other x squared y's. 3xy and 5xy are alike. Sometimes it's helpful to cross them out as you rewrite them so that you don't miss anything. I have negative 2xy squared. Oh my. Okay, I have negative 2xy squared and 4xy squared. So those are alike. And then I have a 6y squared. Okay, again, there was no other x squared y's. So that's a 3. 3 and 5 is 8. Negative 2 and 4 is positive 2. And then there were no other 6y or y squared, so minus 6y squared. Okay, when we subtract polynomials, it's similar to addition, but we have to distribute the negative from the subtraction to every term in the second set of parentheses first. Then we identify the like terms, and then we add them together. So we'll have a few examples here as well. So I want to distribute this negative in. So that is going to change all of these signs. So my first parentheses I can ignore. Then I distribute in the negative, so this positive 2x squared becomes a negative 2x squared. This negative 7x becomes a positive 7x. And this negative 11 becomes a positive 11. Now I have like terms. 5x squared and negative 2x squared are alike. 3x and 7x are alike. And then negative 6 and positive 11. 5 minus 2 is 3. 3 plus 7 is 10. And negative 6 plus 11 is 5. Keeping the variable portion the same each time. Here I'm going to distribute this negative in, and that's going to change both of those signs. Again, I can ignore the parentheses in the first part. And then this positive 6x becomes a negative 6x, and this negative 5 becomes a positive 5. So there are no other x squareds. I have 2 minus 6, that's negative 4. And then 12 plus 5 is 17. Okay, distributing this negative in. The first part stays the same, and then this positive 10 becomes a negative 10. The negative 5 becomes a positive 5, and the positive 1 becomes a negative 1. 13x and 5x gives me 18x. Negative 5 and negative 1 gives me negative 6. And then that negative 10xy is by itself. Distributing in this negative. The first terms all stay the same in the first polynomial. Then that positive 5 becomes a negative 5. That positive 4 becomes a negative 4. And that negative 6 becomes a positive 6. There were no x squared y's to combine. 3xy minus 5xy gives me negative 2xy. Negative 2xy squared minus 4xy squared gives me negative 6xy squared. And then I have that plus 6y squared. Okay, so as long as you remember to distribute the negative to every single term, you should have no problems with this. Okay, here's applied polynomial addition or subtraction. We're going to write a polynomial to represent the walkway area. Okay, the walkway area, don't forget, area is equal to length times width. Okay, so our walkway area is going to be 3 feet times x feet. So that's 3x. Oops, okay. So we'll put A here, 3x. For B, we're going to write a constant term to represent the statue and the fountain area. The statue and the fountain area is 6 by 6, so that's 36. We're going to write a polynomial to represent the green grass area. We have to find the area of the green section and subtract the walkway and the statue and fountain. Okay, so the grass is equal to the whole area minus the walkway and the fountain. Okay, we add those together and subtract it from the whole area. Well, the whole area is going to be x plus 3 plus 2 times this width of x, minus the walkway, which was 3x, and the fountain, which was 36. So this is going to be x plus 5 times x minus 3x plus 36. We're going to distribute that x in. I'm going to have x squared plus 5x, and then I'm going to distribute this negative. So minus 3x minus 36, and that's going to give me x squared plus 2x minus 36. And this would represent the area of the grass. And could we simplify it using addition or subtraction? Yes. Okay, here we have the walkway, but we changed it. And instead of having a 6 by 6 foot, we now have an x by x, and the width is 2x. So we're going to represent the walkway area, which is going to be 3 times 2x, which will be 6x. Then we're going to represent the statue and fountain, so that's x times x, so x squared. And then the green grass area. So the same idea, the grass is equal to the whole area, which is going to be 2x times, that's the width, and we have 2x plus 3 plus 2 minus 6x plus x squared. So this will be 2x times 2x plus 5 minus 6x plus x squared in parentheses. So that's going to be 4x squared plus 10x minus 6x minus x squared, because I distribute that negative. 4x minus x squared is 3x squared, and then 10x minus 6x is 4x. So we did that, and we simplified it, and that's our most simple form.